Hi everybody, it's me again. I want to show you this sample problem here because I think it's going to help you. Let's take a look at this together. This is really important that you do these problems in this method or you are going to have a really hard time doing this. So let's just look at the procedure. I'm going to speed this up a little bit for you. Peak runoff, again, here's your formula. These are all of the different pieces of this formula, and we talked about that in the previous presentation. And I'm going to show you exactly how you find all of these. So this is super important equation here, that your change in runoff has to equal post-development minus pre-development. And that's what you're solving for. It's what engineers use to create a stormwater management plan for the site. And the stormwater management plan would include drainage swales, ditches, detention ponds, things like that. So in this example problem, a developer purchased a 3-acre farm in Nashville, Tennessee. As part of the project, a 20,000 square foot asphalt parking lot will be placed on one side of the 3-acre farm. The 10-year 1-hour rainfall chart indicates that the rainfall amount is 2.17 inches per hour. So I'm going to show you a little bit about how you get those kinds of numbers. So what I want to make sure that you do is you have this written down on a piece of paper pre-development, and then I want you to draw a picture of that. And the way that you draw a picture of a 3-acre farm is you draw a rectangle, and that's it. And then when you do your post-development, if it has a looks like a parking lot and it's 20,000 square feet, you're going to want to find out about how big that is, but you could draw another rectangle and a smaller rectangle parking lot inside there. And having that visual will really help you figure out if you have all the pieces that you need to have. If it said a parking lot and a little house, then you need a rectangle for the parking lot, and from a bird's eye view, a little rectangle for the roof of the small house or shed or whatever that was on there. So again, really important you draw those pictures. Didn't have it in this document, but on pencil and paper you can do that. So pre-development, CF, that table, it's a 10-year storm, and 10-year storms are a CF of 1. The C, this average runoff coefficient for farmland, if I scroll down to the bottom here, farmland over here is 0.05 to 0.3. So I'm going to take the average of those values for farmland, and I believe it says use the average on here. So that's what we're going to do. Average runoff coefficient for farmland. And rainfall intensity, it says see precipitation intensity estimates chart. So we can, when we go to this link on your actual assignment, you're going to see something like this. So if I go into Nashville, Tennessee, and we'll let this load. So here is Nashville. I'm going to click that pointer, go to there. So now I'm at Nashville. You will need to make sure that you change depth to intensity. If you don't do that, this table is going to give you the wrong values. So Nashville, Tennessee, I have a 10-year, the year is on the top in this case, 1-hour storm. It says 2.17. So let's go back and let's see, boom, that's it. So that's where I'm getting those numbers from. And actually, we're still in the pre-development part of the problem. So 2.17 and 3 acres. So we plug all those values in, solve it, and get 1.2. So that's part 1 of the problem. See this right here? See that right here? Part 1. Now part 2, because of my neat little picture that I have of the farmland and then the parking lot, I have 2 problems I have to do here. This one is for the parking lot. You see I have Q parking, and this one is for farm, Q farm. And I would strongly suggest that you write Q parking and Q farm to try to keep it separate so you know you can recognize what it is that you're trying to do. So CF is 1.0. What if I don't remember from that table in my notes? Well, because I love you, I put it down here. So this is your return period. This is your CF value. 1, 2, 5, and 10 years is a 1.0. So boom, there it is. And now this is our chart for all of our C values, our coefficient runoff coefficients. So let's go back up to here. And we can see for a parking lot that was supposed to be asphalt, we need to figure out what that C value is. And looks like I've calculated as 0.825 as an average for this parking lot, because that's what I said we needed to do, is average. So asphalt, if we take the average from 0.7 plus 0.95, divide that by 2 to find an average, and we get 0.825. So that's where we're getting that value. If I would have said we're going to do concrete instead, of course that number is slightly different if we average those. So we have that value in there, 0.825, same rainfall intensity. So you can see I put my I value. I'm trying to label all of the pieces down here. C is always going to be the same as pre-development. Awesome. So is I. Awesome. and sorry, CF is the same. Your coefficient of runoff is different, and your area is probably going to be different. So we've calculated these 30,000 square feet. I think I said it was 20,000 above. Sorry about that value. So this is going to be a little bit different number. But this is just a practice to kind of help you figure out all the steps. So I determine that runoff. I do the same thing for farmland. And again, your CF and your I are the same, so we don't have to refine those numbers. Farmland, we already found up in the pre-development, so you don't have to redo that one either. And the acreage, the area for the farm, we just subtract what we found from the parking. And again, I think that was supposed to be 20,000. I made it as 30, but you get the idea. We add up our post-development values. We add up these 0.82 and 0.99, and we end up at 1.8. Pre-development was 1.2, so I subtract those. I get a 0.6 cubic feet per second. So that is the change in runoff, and that turns out to be a 50% increase. So then we'd have to figure out where exactly that has to go. You can see that I was supposed to do 20,000 again. Apologize for that. So when you do your actual problem, you're going to do two problems, one that's similar to this one that is for the Centaurus parking lot, and you'll use your runoff map to actually calculate that, so make sure you get that. And that should be all you need to do. So make sure that you have some piece of paper that you can show this amount of work. And you can see it's going to take a lot of paper to be able to do that, and showing a lot of work, but it makes it much, much easier to do that. So you should at this point be ready to go.